And if I could turn now to Dr. James Davis.
Thank you, Chair. Professor Wright, thank you again for joining us this morning. What success has the UK Astronomy Technology Centre had in supporting work to repurpose astronomy technology for other sectors?
So if I look at, so if I was to take the Higgs Centre for Innovation, which is more subtle than repurposing technology, because it is about the access they get to expertise. The companies that come into the business incubation there, they typically start as 2-person spin-out type companies. By the time they leave, they've built their workforce to 10 people, so they're creating real jobs and things for which there is a real market. There's about a greater than 90% success rate of the companies that come into the Business Incubation Centre. So that's one aspect. The other aspect is that, much as I think we're going to hear from my colleague at the Open University, we at the UKTC have a small part of our programme that is about actively applying our skills and expertise in real multidisciplinary research. One example would be a retinal densitometer. So it measures changes in your eye that are related to the early onset of eye disease. That's a project that was really led from the University of Cardiff. We worked with opticians and medical scientists at the University of Cardiff. That's in medical trials in Cardiff now. So I think it's an example of a successful use of that technology. STFC has a £4 million a year grant funding scheme that's explicitly aimed at taking the technologies that are developed for astronomy, but also particle physics or nuclear physics. So our big science program, and looking at applications of that, examples are things like how you categorize and count stars and study stars is not very dissimilar to, for example, monitoring populations of endangered species from satellite images. So there's a very successful project around that. There's another one that's around tree cover that's led to very long-term multidisciplinary collaborations. There are people at the University of Cambridge that are looking at medical applications of some astronomy software, using those skills to build virtual reality cancer tumours that are useful for cancer research. So there's a very wide range of applications of these technologies, and it is happening. There's a lot of real multidisciplinary research that comes from the astronomy programme.
That's very interesting to hear. So clearly many applications. Is there potential for more? And in terms of jobs and economic benefit for the country as a whole, what do you think could be realised?
So there is potential for more, and certainly there's a lot of overlap. For example, between astronomy and the environmental sciences. I mean, in simple terms, studying the atmospheres of other planetary bodies is not so dissimilar to turning the problem the other way and looking at our own atmosphere. That's an area where I think there could be a lot of growth, and astronomy is already contributing, but that could grow.
Thank you. Dr. Morgan, do you have any perspectives on the use of astronomy technology in other sectors?
So my background is actually planetary sciences, which is a small part of that. So we develop miniature analytical systems. As I mentioned before, we were engaged by the MOD and BAE Systems. We developed the air monitoring system, which is now on UK submarines. That's broken a 30-year US monopoly on the supply of that, generated 13 jobs in an SME up in Yorkshire. They've signed a very large contract with the MOD to supply those and continuously through. I think the same as Professor Wright, a lot of the investment goes into the people who design the instrumentation and the missions. And I've found it much easier to sell solutions to people's problems. With the multidisciplinary teams you require for space instrumentation, you need engineers, you need chemists, you need physicists, you need a whole range of different expertise, as well as the geologists, the microbiologists, and what have you. And really, the opportunities are just as big as anyone wants to make them.
Yes.
So, for instance, we're now working with a multinational car company using our sniffing technology to make sure their cars are meeting regulations and to also help them reduce costs.
Yep.
As I mentioned at the beginning, we are helping the whiskey industry.
Yes.
So we are capable of identifying more compounds in complex samples. Whiskey is very complex, as are other distilled spirits. And in collaboration with commercial companies, we're able to apply new tools to help answer questions. How long should you leave a whiskey in an oak barrel for? What happens to the chemistry? What happens if you change the recipe? What happens if you change the process? So there's a whole range of different applications.
Maybe a separate inquiry into that. One final question to Professor Wright, if that's okay, and that is, what lessons can you learn from analogous organisations in other countries, so organisations that do what you do in other countries?
So I think it's around funding of early stage things before they become very real. So there's a lot of discussion in the astronomy community at the moment around what will be the successor for the James Webb Space Telescope, the next big NASA flagship mission, which will be looking for biosignatures in the atmospheres of planets around other stars. That mission is just in the very early stages of both the discussions amongst the astronomers about what does it really need to do, but also the beginnings of technology development studies for the new technologies that will be able to drive that mission forward. And if I look in countries like France and Italy, they're already very organised in terms of technology development studies, in ways that while we're having some very high profile scientific input to the discussions of the missions and the science is funded, the technology development is maybe not. The very early phases is something that where the funding is quite hard to find in the UK at the moment, because it's not yet a real mission.
Mm-hmm. Thank you, Chair.
Thank you. And finally, James Davis.
Yes, thank you, Chair. So on to artificial intelligence. And firstly, Professor Anand, what use does Planetary Science make of AI so far?
A huge amount. So we collect a huge amount of data from spacecraft missions which are going around planets. So for example, we have missions that are going around Moon, Mars. There is a mission that is on its way to Mercury. It's been 10 years in the making. So we, as a UK community, are looking forward to that. Once that data comes back, so far, it has been individuals who are sitting in front of their computer, downloading the data and, looking through it, and just the first cut through. Now we are using AI to that effect to actually do the first pass so that they actually identify some of the important and interesting bits, so that then a human can pick it up and maximize the output from it. So that's one example. The other use of artificial intelligence in planetary missions is that when these spacecraft are around these bodies, they have to take some autonomous decisions based on the data they collect there. Part of it is what didn't work for the intuitive machine, why it wasn't successful, but this is the development. I mean, this is where things are going. So the future is going to be very much robotics, AI-driven, with human involvement. So that's how I see AI being used.
Really good, thank you very much. And if I turn to Ian Jones, Professor Anna Scaife told the committee that AI was going to be really important in terms of processing and making sense of the large quantities of data that arise through astronomy. Do you think that Britain is well placed to take advantage of that?
I certainly do. The scientific community really understands AI uh, and has this real need to get to the bottom of the useful information, particularly as developed in the radio astronomy community.
Yeah.
In order to look back to the beginning of the universe, you need to collect a huge amount of data and process that data. In fact, more data than is currently moving around the world on the global internet.
Yeah.
So it's really important to be able to narrow down the required information from that. And I think the UK has a great capability in understanding how that's done. But I think we tend to think of AI as a sort of modern invention.
Mm.
The roots of it go back, I would say, a couple of hundred years ago, and the logic and the mathematics that we use. And in the communications field, we use a similar but related sort of capability. You could determine, you could call it digital signal processing. And we use digital signal processing for many purposes, to make our mobile phones work, to communicate with satellites. And this works on very narrow amounts of data and processes that data very deterministically, but uses, as I say, the same bedrock of mathematics. And I think in the UK we have the ability to do both of those.
Mm.
So to give you an example, if you were collecting huge amounts of data from the universe and you wanted to determine a process that was going on, to form a galaxy or whatever, AI would be a fantastic tool to use. But if you wanted to do, an international financial transaction, you wanted to, buy something from online from America, you absolutely wouldn't want to use AI. You would want to use digital signal processing and make sure that, that the amount that you put in on the form on the website was the amount of money that was taken from your bank, and you would want absolutely zero chance of there being an error.
Yeah.
And currently AI doesn't give us that, but we have other tools, as I say, the digital signal processing that we're really good at in the UK, that can do that. So I think we have the ability to do both.
Mm. Okay, and in terms of AI, how are SMEs in this country, such as yours, able to exploit the opportunities?
So I think this is a really interesting point. Obviously, there are the online services that everybody is coming to understand and to use. So that's a process, I think, that we all need to learn about and get better at understanding. There's I think that's something which will come across the board in terms of companies. But if we look at the technology companies that can really use AI to make a significant difference in the economy in the UK, I think we probably need to do more in terms of the interaction with universities. I think a lot of the development is done in the academic sector at the moment, and yes, it's a real challenge, I think, to see how we can use those how those techniques can be rolled out more broadly across industry. So we will be using AI for example, for surveillance of space and doing a lot of data processing. Of trying to find out where space debris in space and satellites are in space, processing very large amounts of data but low contrast, low signal to noise data. But we'll also be using very, very much those techniques of digital signal processing as well.
Okay, so you said that the challenges that exist can be overcome in part through better liaison with universities. Are there any other challenges you see or solutions that you want to highlight?
Yeah, I think a lot of the UK money, I would say, is going into the university sector, quite rightly, at the moment. And the Alan Turing Institute and the funding that's going in to create these AI-specific data processing data centers. That's all good, and that should be done. I think what could be done better is having programs which allow particularly technology and manufacturing industries to gain access to the research and development that's being done in universities. We've heard a lot in terms of the evidence here about spin-outs from universities, but that's not the route that all technology companies use to start up. Many graduates leave the university sector, perhaps to work in industry for a few years, and then set up a company. So, activities to really get universities and academia working more closely together is a real challenge. I don't think it's been solved perfectly yet, and we could do more to think about that, how that could be done.
Okay, thank you. Professor Scaife also told us that using AI for astronomy could then lead to AI itself being trained for other purposes. Do you have any comments on the opportunities in that field and whether this country is succeeding?
Radio astronomy is a massively multidisciplinary field. We use the outputs from radio astronomy for our work because the radio astronomers can produce instruments that we can use that are of much better quality for receiving very faint signals or for extending the frequencies that of interest that we can use. But then when radio astronomers have received that data, they do image processing. They are often trying to extract, very poor information out of very poor quality data, and so that has a massive amount of impact. We've already heard a number of witnesses talk about the implications to the medical field, and very often the capabilities, particularly around processing of data, and that includes AI, becomes used in the medical field. So yes, there's many opportunities for the skill set developed in the astronomy community to move across to other sectors.
Fantastic, thank you. Well, I think the bell is about to ring for Wales questions.
It certainly is. So thank you, James, for